Welcome to the sixth video in the Raspberry Pi tutorial series. In this tutorial we will look at the GPIO, and the Python programming language. We will build a simple electronic circuit, attach it to the Raspberry Pi's GPIO header pins and write a simple program which will output to the circuit. The Raspberry Pi provides the user with a gateway to computer programming, electronic engineering and robotics. Many projects have been demonstrated on the internet showing what can be achieved, and the project details have been published for others to try. The Python programming language is the ideal introduction to computer programming. It is available on almost every operating system and can be used for mathematics, computer game development, network programming and so much more. The software is free and open source and comes pre-installed on the Raspbian Linux image. We will now demonstrate how to access the Python console from the terminal window. Then we will write a simple, "Hello World," example program and run it to see the output. To access the Python console we type sudo python. The console starts and shows the current version of Python. The prompt for the Python console is shown by 3 greater than signs. Code can be typed into the console a single line at a time. This is used to test code and perform commands without a script. We will print a simple calculation and the console will return the answer. To do the calculation we type print 3 plus 4. The console returns the answer of 7. We will try a more complex calculation. At the console we type print 4000 times 65. The console returns the answer of 260,000. We can also output text by using the print statement followed by text in inverted commas. To do this we type print hello. The console outputs the text to the screen. In this example we have used single lines of code to produce an output. We will now quit the console and write a simple Python script. To exit the console we type quit followed by open and close bracket. This will return us to the normal Linux terminal prompt. To create a Python script we type sudo nano-sample.py. The py extension tells the system that this file is a Python script. In the nano editor we will type one line print hello world. As we are outputting text we need to have inverted commas at the start and end of the text, otherwise the script will produce an error. To save the script we press Ctrl and X and save the changes. To run the script from the terminal prompt we type sudo python sample.py. This outputs the text, "Hello World," to the terminal window. Python can also be accessed from the desktop by running the program called idle. To learn more about the Python programming language and try out more sample code, check on the internet. There are numerous excellent resources for Python. We will now discuss the GPIO pins on the Raspberry Pi. The GPIO consists of 26 pins. Each pin has a function. Pin 1 is marked on the circuit board with the symbol P1. Pin 2 is to the immediate right. Pin 3 through to 26 are as shown on the diagram. Pin 1's function is to provide a 3.3 volt power supply to a circuit. Pin 2 provides a 5 volt power supply. Pins 3 and 5 are the I2C0 pins. These are specialist pins and normally used for external peripherals. Pins 4, 9, 14, 17, 20 and 25 are DNC pins. These pins are not to be connected. Pin 6 is the ground pin. This provides the negative power supply for a circuit. Pins 7, 11, 12, 13, 15, 16, 18 and 22 are the programmable GPIO pins. Pins 8 and 10 are UART and are used for transmit and receive functions. Pins 19, 21, 23, 24, 26 are the SP10 pins. These are used for special functions. The following diagram shows the complete pinout for the GPIO. This diagram is essential when creating programs which will output to an external circuit. Later in the tutorial we will create a program which will output a signal to pin 7. This pinout is for GPIO revision 1. In newer models of the Raspberry Pi this has been upgraded to revision 2. We can verify the revision of the GPIO used by opening the Python console and typing 2 lines of code. Using the correct case when typing commands into the Python console is very important. Type in exactly as shown or an error will occur. The first line of code is import rpi.gpio as GPIO. This line of code imports the GPIO library into Python. The second line of code is gpio.rpi_revision. When enter is pressed on the keyboard, the console will return the revision number. In this tutorial we are working on revision 1. It is important to check this as the pinouts will vary on each revision. We will now discuss the external electronic circuit we will connect to the Raspberry Pi. We will create a simple circuit using a LED and a single resistor. The components can be connected using a solderless breadboard and male to female jumper wires. We will then use Python to light up the LED for 5 seconds, then turn off again. An LED has 2 terminals. A positive terminal called the anode and a negative terminal called the cathode. The positive terminal is always the longest terminal on the LED. To calculate the correct resistor for the LED we need to know 3 variables: the power supply voltage, the LED forward voltage, and the LED forward current in milliamps. The Raspberry Pi will supply 3.3 volts. The diode used has a forward voltage of 1.95 volts and a forward current of 30 milliamps. Using an online LED calculator we can see the value of the resistor needs to be 47 ohms. We can tell the value of a resistor by looking at the color bands. Each band has a value according to the color as shown. The first band is yellow, which has a value of 4. The second band is violet, which has a value of 7. And the third band is the multiplier, and the value of this is 10 to the power of the color value. The band is black and has the value of 10 to the power of 0. The fourth band is the tolerance band. A gold band shows that the resistor has a tolerance of 5%, which means the actual value will be 5% above or below 47 ohms. The circuit is wired up as follows. It is important to ensure the Raspberry Pi is powered off when connecting cables to the GPIO header. We connect a wire from pin 7 to the positive terminal on the LED. On the negative side of the LED we connect one end of the resistor. From the other side of the resistor we connect the wire back to pin 6. Pin 7 will be programmed to output a signal and power up the LED for 5 seconds. Pin 6 is a ground pin and used to complete the circuit. The resistor will limit the current passing through the LED. With the wiring in place, it is now safe to power up the Raspberry Pi. We open the terminal window and create a Python script which will output a signal to pin 7 and light the LED for 5 seconds. The script is as follows. We will discuss each line in detail. To create the script we type sudo nano led light .py. Line 1. Import rpi.gpio as GPIO. This line imports the GPIO library into Python. Line 2. Import time. This line imports the time module. Line 3. GPIO set mode bracket GPIO board bracket. This line sets the program to use board numbering. Line 4. GPIO setup bracket 7 GPIO.out. This line sets GPIO pin 7 to out. Line 5. GPIO.output bracket 7 true bracket. This line turns GPIO pin 7 on. Line 6. Time sleep bracket 5 bracket. This line instructs the program to run for 5 seconds then stop. Line 7. GPIO.cleanup open and close bracket. This line resets the GPIO pins. To run the script we exit back to the terminal command line and type sudo python led light.py. The script lights up the LED for 5 seconds then stops. as the Raspberry Pi can be connected to remotely. The script could be run from any device which is connected to the Internet. The GPIO can be used to power motors, allowing the user to build remote-controlled vehicle projects. The Raspberry Pi also has a port for a camera to be fitted, which could allow the user to build a remote-controlled vehicle which will relay pictures back. The potential for learning with the Raspberry Pi is almost limitless. We hope you enjoyed the 6th video in the Raspberry Pi series. Please feel free to ask questions and leave comments, and please subscribe to the channel.